Hi, Algebra 2 Honors students. This is Ms. Skokin. We're going to take a look at Section 2-9, Operations with Complex Numbers. As always, we have a little warm-up that we're going to work on, so I'd like you to pause the video right now and turn it back on when you're ready to check your answers. Remember that if you need to look back on your notes from previous sections, you can do that. Hopefully you didn't have any difficulty with any of those questions, remembering that the square root of -1 we write as I. The complex conjugate, we change the sign of the imaginary component. And when we multiply radicals, when we have these two binomials that we're multiplying in numbers 5 and 6, we FOIL, just like we do with whole numbers. Okay, we have an objective, perform operations with complex numbers, and we have some new vocabulary that we're going to take a look at. Pause the video once again and read this introduction. So stated very simply, in order to graph a complex number on the complex plane, what we're going to do is treat the horizontal axis, what we used to think of as the x-axis, we're going to graph the real number component, and on the vertical axis, what we used to think of, or what we normally think of as the y-axis, we're going to graph the imaginary part of the complex number. So here's an example of what the grid would look like. And you can see we have the real axis and the imaginary axis, just as I described. And you can think of the complex number a plus bi as x plus yi. Now, pause the video and try to graph each one of these four complex numbers in your class notes. Turn the video back on when you're ready to check your answers. And also remember to label the points. All right, once again, hopefully you didn't have any trouble with graphing those. Remember, the real goes on the horizontal and the imaginary goes on the vertical. Just as we have graphed before, you shouldn't have any trouble graphing on this grid. If you do, write your question down in your notes and we'll go over them together in class. Okay, so now let's talk about another thing that we can do, and that's on this complex plane where we have a real axis and an imaginary axis. Let's say that what we want to do is we want to find the distance between 0 and one of those points, one of those complex numbers. Well, we know that in the real plane, coordinate plane, the Cartesian plane, we use the distance formula to find the distance between 2 points. And we also know that distance away from 0 is known as absolute value, and we use absolute value bars to designate that. So what we're going to do is use absolute value bars to designate when we want to find the distance between 0, which is the origin when we're talking about a plane, and the complex number that we've graphed, that we've just learned how to graph. So you can see an example here. Pause the video if you need to take a closer look at the example so you can see how to come up with the magnitude or the distance between 0 and the complex number. All right, so now you have an example. Pause the video. Using the format, I guess is the best way to say it, that you saw on the previous slide, find the absolute value or the distance from 0 of each one of these complex numbers. Turn the video back on when you're ready to check your answers. Here are the answers, and if you need to pause the video again to sort out any problems and copy them correctly into your notes, you can do that before you move to the next slide. When we talk about operations with complex numbers, we know that we're going to be combining them in some way. And the first thing that we're going to do is look at combining them through addition and subtraction. When we add or subtract complex numbers, it looks just like when we combine numbers that are like terms. So that's how we're going to be working with these when we add or subtract complex numbers. We're going to add the real part to the real part, add the imaginary part to the imaginary part, and if we started out with a complex number, we're going to still end up with a complex number. So remember the properties that we've used in the past, commutative, associative, and distributive properties. We're going to continue to use those properties here. And just a reminder, the additive inverse of a plus bi is negative a plus bi. Notice that minus sign on the outside of the parentheses means we're going to need to distribute. It's like multiplying through a -1 to each one of the terms inside the parentheses. So pause the video now. Remember, combine the real part to the real part and the imaginary part to the imaginary part. Your answer is going to end up being a complex number. Turn the video back on when you're ready to check your answer. Remember as we go through to copy these into your notes. Hopefully you were successful in adding these two numbers, and we'll take a look at the next example. This time we're going to be subtracting, so just as we did before, we're going to combine the real to the real, the imaginary to the imaginary, but don't forget to distribute that minus sign as if you're multiplying through a -1. Okay, so you should have ended up with 7 plus I, a complex number. That's the result of subtracting two complex numbers. Here's another example to try. Turn the video back on when you finish this example and you can check your answer. Okay, so this one resulted in 0 because we had exact additive inverses of the two numbers. We can also add complex numbers using geometry, and that looks a little bit different. This is a kind of a preview to what you're going to see next year, both in pre-calculus and for some of you next year will be physics. For others of you it'll be in 2 years. But what we're going to do first is graph the two complex numbers. And after we graph the two complex numbers, we're going to make them into a parallelogram. So we start out with the two complex numbers, we draw segments to the origin, and then we create a parallelogram with those two complex numbers and 0, the origin, as the three vertices. We create the last one, and the result of that fourth, wherever that fourth complex number is, that is the sum of our complex numbers. So we can check our answer by adding them algebraically as we did before. We can also multiply complex numbers the same way that we have before, using the distributive property, using FOIL, and then also remembering that the square of I, or I squared, is equal to -1. So you can see that we have an example here. What we're going to do is distribute that -2i to the two numbers inside the parentheses. We end up with an I squared, and so what we need to do is substitute in for I squared -1. And that allows us to come up with the complex number that we end up with, -8 minus 4i. The other thing that you need to remember is sometimes we're going to end up with a real number, and sometimes we may end up with a pure imaginary number. When we do this combination, whether it's addition, subtraction, multiplication, or division, we may end up with we're always going to end up with a complex number, because remember, complex numbers includes both real and imaginary components. Okay, here's another example. Pause the video while you FOIL these numbers. Remember to substitute in -1 when you end up with an I squared. Combine like terms and then turn the video back on so you can check your answer. Okay, here's the answer to this one, and hopefully you ended up with the correct answer. If you have a question about this, jot it down in your notes and we'll go over it in class. Here's another example to try, and this one is special because you're multiplying two complex conjugates. Once again, turn off the video and turn it back on when you're ready to check your answer. So we knew something special was going to happen because we were multiplying two complex conjugates. The middle terms fall out and we end up with a real number. We remember real numbers are part of complex numbers, so we still ended up with a complex number, but it has only a real component, no imaginary component. One more to try. Multiply these through and remember to substitute in for I squared if you end up with it. Check your answer when you turn the video back on. If you have any questions about this or any of the other examples, remember to jot them down in your notes, and we'll discuss them in class. We talked about powers of I previously, and remember that we saw a pattern, so we only really need to memorize I to the first, I squared, I cubed, and I to the fourth power so that we can use a repeating pattern. And we're going to try some of those examples next. So we want to simplify this number. Turn off the video, refer back to your previous notes if you need to, and turn the video back on when you're ready to check your answer. Now, the way that we did it in class is slightly different than this example because if you remember, we took the exponent and we divided it by 4. 14 divided by 4 would be 3 remainder 2, and so we know we're going to end up substituting in for I squared. We're going to end up substituting in -1. Hopefully that helps bring together what we did in class and the slide here. So again, if you have a question, jot it down. We have another example. Turn off the video, practice, and then turn the video back on when you're ready to check your answer. The way that we did this one in class is we took 63, we divided by 4, that gave us 15 remainder 3. And that remainder 3 is going to indicate that we have this negative I result. Okay, now our favorite one of all, it's when we divide complex numbers. And just a quick refresher, we cannot have radicals in the denominator. That's not simplest form. So in order to get rid of radicals in the denominator, we rationalize. And remember that I is the square root of -1. So if we have an I in the denominator, we need to get it out by rationalizing. So let's take a look and see how we do that. What we're going to do is multiply the numerator and denominator by the complex conjugate of the denominator. The numerator and denominator being the same number means that we're going to be multiplying by 1. It's just not going to look like 1. It's going to look like the complex conjugate of the denominator. And that's going to allow us to have the middle terms fall out, so we end up with only a real number in the denominator. Let's take a look at an example. With 5i in the denominator, the complex conjugate is -5i. So we multiply by -5i over -5i, which we know is equal to 1. As we expand that out, we end up with an I squared in the denominator. We know we're going to substitute in -1 for I squared, so we're going to have a complex number in the numerator and a real number in the denominator. Our result is still a complex number, but you can see that we have no more i's in the denominator, meaning we have no radicals in the denominator. So we're in simplest form here. Although it looks like all of these numbers are divisible by 5, so I think we could simplify it a little bit further. Okay, we have another example. This time we have 4 minus 2i in the denominator, so we're going to multiply by, you guessed it, 4 plus 2i in the numerator and in the denominator. As we FOIL the numerator and FOIL the denominator, combine like terms, and substitute in for -1 for I squared, we can come up with the simplest form of this fraction, of this new complex number. That brings us to the end of section 2-9. So we know, since we're at the end of the chapter, we're going to have a test coming up soon. Remember to make sure, get caught up with all of your homework for chapter 2, because chances are you may want to be able to retest on this material, and your homework is essential in getting you prepared. See you in class.